Hello everyone, Dunja speaking from Croatia, from Zagreb. So if you agree we can start now. We have nice spring weather here in Croatia. So I will start with the EFI of ECMWF, which shows that we have quite a large warm anomaly in the most part of the Europe. Namely in the southwestern part of Europe, in the Mediterranean, but as well in the central part. While the northern part of Europe, Scandinavia, still has a cold anomaly. But the biggest part of Europe is in this warm sector of a huge system, which we will handle lately. So I just wanted to show you this to show you that we have weather which really looks like we are in the middle of the spring and not in the middle of autumn. While some normal temperature here in Zagreb, which is here, in this part of October should be around 15 degrees Celsius. We had 22 degrees yesterday. So this is what I'm showing here. But nevertheless, in the next few days, most of Europe will be having this warm weather. And Scandinavia as well will be also experiencing this huge warm anomaly in the next 3 days or 4 days. So this is just to show you the present situation and what I'm feeling right now. So this is the weather briefing content. I will start with an overview of the last month in Croatia, which was very rainy, especially in some parts of Croatia. And then we will go and check the present situation as usual. So this is the precipitation anomaly for last month in Croatia. So for those of you who are not familiar with the geography of Croatia, we have this nice shape as a croissant or as an alligator looking back to, let's say, Eastern Balkans. In this northern part of Croatia, which is the valley part, we had this positive anomaly of precipitation. So we had quite a wet September, last September. But what I wanted to show you was not this, but this small part of Croatia, this small dot over town of Rijeka. And if you look more closely, you can see that here you have a number of 250, which means that we had a plus 250% of rain in regard to the normal, to the September normal. What is interesting is that given this fact that it was 250% more rain, it still wasn't the extremely wet September. So it was the third extreme weather event, extreme September in history in town of Rijeka and its vicinity. And if we look into the climatology of September and in the climatology of the autumn precipitation, we can see that in this northern part of Croatia, we are not used to this rainy season, so the September is not so rainy. But in this mountainous part here, especially in the vicinity of Rijeka, we do have this big amounts of rain, which is more than 900 millimeters during those 3 months. Small geography lesson. So let's check where we are. Since this is the first weather briefing held by Croatia since Croatia joined European Union, now I'm proud to show you that this part of Europe is also actually a part of Europe. And so we are here, and we have this nice geography in which we have this valley part right here, mountainous part here, and of course the seaside, the coast, and the part of Adriatic which belongs to Croatia more or less. So forgive me if I wrote, if I drew bigger than it actually is. So here in the weather office, in the forecasting room, we have quite a lot of work because we have quite a geographically or graphically diverse country, and we need to handle the maritime part of Croatia, the mountainous part, and the valley part, which is behind those mountains. The reason why I'm showing this particular part of central Mediterranean is because I'm sure that you know that this is one of the most cyclogenetic parts of Europe, especially of Mediterranean, and it is not so. It is very common that cyclones develop right here in Genova Bay. Sometimes they are connected to the cyclones which have this track 5A, which come from here, and then they develop here, and then they move along the Italian coast and go down there, or they come into the northern Adriatic, and then the tracks can be a bit diverse. So we have the 5B, 5C, or 5D track, which is the most common one. But it's not so uncommon that also another cyclone develops here, and then we have cyclone sisters. So one in the Genova Bay and the other in the northern Adriatic. Together with the geography of northern Adriatic, it can develop quite a mess here. So just a short introduction into the town of Rijeka. So this is the third biggest city in Croatia with almost 130,000 inhabitants. It is situated in Bay of Kvarner, as I showed you. So here. So this is the Bay of Kvarner. And in the back, here, it has mountains. So this is the Dinaric Alps, the part of the Dinaric Alps. And the nearest mountain is the Risnjak mountain, which is 1,500 meters high. So quite a complex orography. So it makes sense that the climatology of precipitation looks like this. So we have annual mean of precipitation around 1,500 millimeters. So it is quite a lot. And we had the maximum in 1960 when we had 2,339 millimeters of rain in 1 month. A September mean is 200 millimeters. And this September, 2013, we had 400 millimeters of rain. And it was the third, as I said already, third monthly amount of rain in history. But we had one record, and this was the daily amount of precipitation, which was the highest daily amount ever measured, and we have the measurements since 1948. And on this particular day, the 29th of September 2013, 250 millimeters fell, and this was not only in one day, so this was not actually the daily amount, but it fell in half of days, so in 12 hours. It was really an extreme event. So this is what the traffic looked like. So it doesn't look so bad. It was only 30 centimeters of rain, which had no place to go. And this is the precipitation measurement from the automatic station, which shows that the rain was falling during the day, 29th of September, and most of the rain fell during the afternoon hours. And one maximum, I'm sorry, but it's not so visible here, but it says that it was 16 millimeters in 20 minutes. So it was quite an intense precipitation situation. If we look at the situation and see what happened, then we can see a huge cyclone, a huge low, very well developed in the upper levels as well. So here we have this low, and at the front side of this low we had this upper level trough reaching from the northern Adriatic through Bay of Biscay to the Alps. So we can say that it was a more or less typical situation. And at 300 hectopascal we can see a cold drop, which was nicely developed here in the over the western France. At the surface, in mean sea level, one low was detected, but you can also see quite nicely that there were also two lows, one here in the Genova Bay and the other, as I already explained, in the northern Adriatic. So it is not difficult to say what the stream looks like. So we had the stream which was perpendicular to the mountains, coming from the moist Mediterranean to the Croatian coast. And here in the surface wind or 10-meter wind field, we can see again two cyclones, one here and the other one here. And we can also see the convergence line, which was causing this intense situation just here over the city, the town of Rijeka. Okay, so this was the history, and now to the present situation, to the situation from the last night. This is the 0 UTC air mass RGB. So again, or still, we have this low system which was nicely developed here, and a few frontal systems ahead of it. Here is the upper level low, so this is the 500 hectopascal low. Very nice feature here in the central part of the eastern Atlantic, and the very, very pronounced, nicely pronounced southwestern stream over the biggest part of the continent. So this is a kind of untypical situation because the low is still very much to the south. So it's it's more to the south than we are used to in this part of the year, and this is the reason why we have such a warm weather and warm anomaly here in this southwestern part of the Europe, as I said at the start. Looking further into the situation in the upper levels, we can see a jet stream behind this system, and a nicely pronounced front, cold front, connected to this system, and a PV anomaly at the back of the frontal system. But in the low levels, we can see that there is much more than this one system happening. So just to see if you're all awake, let's draw the lows. Could you please put the, let's say, put a star where you think the lows should be? Okay. Is there some other low here? Okay. Okay. Okay, this is more or less correct. There's one missing. There's one missing. Okay. Okay, we have, yeah, okay, so this is the one, yeah. This is the one that was missing. Okay. So the situation is quite nice and quite diverse. We have a lot of things happening here in this warm air over the continental part of Europe. But the most pronounced system was definitely this one here. That was producing some convective weather. So we have also some convective weather here, near to the lows that you all pointed, but this one was really the nicest one, and we had quite an intense night over the northern part of Italy and the northern Adriatic and the western part of Croatia. So in the enhanced infrared image, we can see that the temperature of this particular system was lower than 200 Kelvin. So this is really quite a high, quite a nice convective system. I'm sorry, but this was the only radar image available to me. Of course, the main part of the convection was happening here actually, but this is something that I had available, and this is the this is the rain that was this convective system was producing over the western part of Croatia. So the rainfall rate was around 10 millimeters per hour. And we can see that there were a lot of thunder and lightning events. So we had over 1,500 lightning strikes per minute during this intensive period of convection. And this was, of course, the mesoscale convective system. So we saw that it had the size of more than 200 kilometers, and this cloud top temperature was less than 70 degrees Celsius. And of course, it was it had an oval shape, which fits to the conceptual model. We can look at the vertical cross section. Unfortunately, it was not. It would be much nicer if it was here, but we should we have to use what we have available. So I'm using this one, this yellowish, orangish one, which starts here and then somewhere down there in the eastern Mediterranean. And we can see, so our system is supposed to be somewhere here. Let's say the frontal part of this system should be somewhere here, over the Croatian mountains. So we can see that we have a lot of humidity, even in the upper levels, as high as 300 hectopascal, and that we have quite nicely pronounced vertical development also in this upper levels, so as high as the upper troposphere. Another feature which was very nicely pronounced in the satellite image, and it was much nicer in the infrared, is this bulge here, which is classified as a wave. So let's take a look at the weather at the parameters to see if it fits the conceptual model of the wave. So we have low, and we have this mean sea level pressure minimum immediately to the rear of the cloud bulge. We had a combination of warm and cold anomaly temperature advection. So we have warm advection here at the back of the within the frontal system, and the cold advection behind. But here in this part, I guess I would say that this warm advection is missing. And of course, in the upper levels, so we had the PVA maximum, which is supposed to be at the back, downstream of cloud bulge, and the trough behind the frontal band. So I guess I would say that this is the wave, but maybe someone more experienced should say if I'm right or not. No one? Okay, I guess I'm right then. This is what I thought that this were the main features, the most pronounced features in the today's, or let's say tonight's situation over Europe. And now, again, I need to check if you're all awake, and I would ask you to draw or to point where the cold fronts are. Okay, this one is easy. Are there some more? Okay. Okay, so this one is correct. Okay. This here is partly cold front, but mostly this has occluded already. This one is correct. This one is, of course, very correct, the most obvious one. And what about this one here? Is it actually a cold front? It looks like a cold front at first, and it has a shape of a cold front. Okay, yeah, thank you, whoever that was. Thank you very much. This was also thought in my mind when I saw the satellite image. A big question mark appeared, because this really looks like a cold front, and it's very easy to be misguided by its shape. Let's take a look at it. Okay, this is the thermal front parameter, so we can check again if you were all right. We have this front here, we have this one here, we have this here, this one here, and this is, there is something happening in the thermal field, definitely, but let's see what it is. Again, I'm sorry if you cannot see it, but the synoptics is messy. So we have a big ridge here. It is obvious, but there is something even more pronounced here. So actually there is a ridge here, thickness ridge, behind this this frontal system. Is there a jet near this front? No, there is no jet. The jet belongs to this back rear part, to the actual cold front. And here, near this system, we do not have jet. And if we look at the temperature advection, then we can see that we have warm advection, a big system, and here we have warm advection within this frontal cloud band. Let's take a look at the vertical cross-section and see if it can answer the question what kind of a front this is. So I will take the orange one again, or the brownish one, whatever. So let me just point out that this is the start of the vertical cross-section, and this is the end. So we're cutting the fronts, both fronts, this one and this one. So we will see this one first, this one, at the left-hand side of the vertical cross-section, and then we will see what is here, near to the medium part of the vertical cross-section. So this is the vertical cross-section. This is obviously the cold front here. And this is our system, the one that we were interested in. So what kind of front is that? Again, let me remind you that it was cross-cut. Yeah. Okay. Thank you. Here we have the again something that we can check and see, and we can now be definitely sure that this is the warm front, because we have the convergence in the front, within the frontal system, and on the top of it, and warm. The where is the I don't have the temperature advection, but anyway, the warm advection maximum is also within the frontal system. So, looking at the vertical cross sections cutting through the fronts, we can see that this is definitely warm and not the cold front, as most of us thought when we saw the satellite image at first. So this is what I have prepared, and I would ask somebody else if there are some questions or some comments. Please ask, comment, speak. Vesa, help.
Help? Well, you are doing very fine there. I'm happy to see your vertical cross sections, by the way. Some people were missing them, and they are back since last weekend.
Yeah.
I wanted to make a comment on this picture, but well, you see there's a lot of detail.
Yeah.
The fact that the black isolines are even interpreting the meaning of the black isolines can take a few moments, because they are the isentropic or the equivalent potential temperature, and you see the lots of information even in the black isolines. But when you point out the front like you did, then it helps also to understand what's the situation in ahead of the front, and then on the other hand behind the front.
Yeah.
Convergence and divergence is always quite noisy field.
Yeah. Okay, but the maximums are quite nicely pronounced, so you can see that there is a maximum here, and of course here in the cold front.
If I may still add one thing I saw on the text chat box, that Robert was asking about where the cross-section data comes from, and Milana already answered that it's coming from the ECMWF.
Yeah,
we are
sorry,
using for... Yeah,
I'm
we
not
are
so
using...
experienced in this presenting via Centro, so I was not able to check the text box.
Yeah, it's so normal. We keep an eye on that for you. So there's this ECMWF model has, if I remember right, we selected 0.225 degree resolution. Sometimes it's better to actually not take too much detail for the web presentation. The very detailed output of the LAM models can really get really messy pictures you can get. So for a broad overview, it's sometimes easier even to have 0.5 or even 1.5 degree resolution. Back to you, Dunja.
Okay, so there was just one thing that let me find a satellite image, one of the satellite images. I wanted to ask you, but it is more than clear. And in regard to the first part of my presentation, so I wanted to ask you which part of Croatia you think that today would get maximum precipitation. So since the situation is more or less similar, we have this southwesterly flow, and of course we had already this system which was going over the northern part of Adriatic coast. So then again the answer to this question is of course Rijeka. So thank you for your attention. This was more or less all that I had prepared, and I have to remind you that the next briefing will be held on November 14th by Vesa and Zanita from EUMeTrain.